Welcome back. So in this video, I will demonstrate task one, like packaging CI/CD workflow into reusable Cloud Skills. So the requirement that specifically asks to see like clear execution boundaries, safety awareness, uh, idempotency, and how precisely the skills are triggered. So I will use this deployed UI to show you exactly how these are handled under the hood. So here in the UI, you can see the inputs. So the target repository URL, the branch and the skill built in here, and mandatory like we can run a skill toggle. Okay. So for the first thing, maybe I can use another public repo here. This is another repo that I built, and maybe let's use like lint and test skill on the real repository. So let me hit the run. So as I hit the run, let me explain the idempotency mechanism under the hood. So the system doesn't just like blindly clone the repository every time. Instead, it makes a single ship REST API call to GitHub to fetch the latest hit commit SHA. So it then builds a cache key using the repo branch skill name and the commit SHA. If the code doesn't change, the system hits the cache and returns the exact same results instantly. So this means that zero clone time, zero execution time, and exactly zero cost on the repeat runs. So I completely just eliminates the redundant compute. And maybe a next skill that I can show would be like dependency audit. Uh, okay, so let's talk about like mm, auth and safety awareness. So which was a critical grading criteria in the prompt. So when a skill like dependency audit or security scan actually runs, it executes like inside the restricted subprocessing box before any comment is executed. So the system proactively strips all sensitive environments variables like the GitHub token, OpenRouter key, and NVIDIA key from a trailhead hood. And furthermore, like when we clone private repos, the GitHub token will embedded in the clone URL is aggressively redacted into the asterisk before a single line is written to the structure logs. So even if the agent is running against a malicious um, maybe repo designed to explorate the secrets, the attack will fail because the secret simply aren't there. Okay, so maybe the next repo I can do is like uh, we can use some like build and release parts and maybe try other kinds of like clicks here. So finally, let's just look at the inputs and outputs, especially for write actions. For skills like build and release, the system forces like strong, I have parameter code try run equals to true by default. So you will never create a real git tag or release without explicit human opt-in. Establish a hard safety boundary. Yeah, so after the skill executes, the system makes exactly one error in code to generate a human-readable summary based on the deterministic JSON outputs. When merging the final result payload, the engine level fields like the summary and confidence score are applied last. And this is a deliberate design choice so that a malicious script from the repository can override the engine summary by outputting conflicting JSON keys. So in short, the test one demonstrate how to package ARM operations with enterprise-grade caching, strict sandboxing, and fallback-driven execution. Okay, thank you. And in the next video, maybe I can walk through the browser automation agent.